and we will see one small problem. So design a basic wide band RC band stop filter. Remember RC band stop filter. So we are not talking about the active band pass filter. We are talking about the passive band stop filter with the lower cutoff frequency as 200 hertz and higher cutoff frequency as 800 hertz. So FL is equal to 200 and FH is equal to 800. The unit is just hertz. Find the geometric center frequency, that is the resonant frequency FR, minus 3 dB bandwidth of and Q of the circuit. So the upper cutoff frequency, upper and lower cutoff frequency points for a band stop filter can be found using the same formula. So FL or FH is equal to 1 divided by 2 pi RC. You have to use the correct R and C values, and then you can find this one, FL and FH. But they had already given here FL and FH. Okay, so now let us just assume the capacitor values for both filter sections as a 0.1 microfarad. The values of the two frequencies determining resistors, this RL and RH. Here you see they did not give the resistor values. They did not give the capacitor value also. That is why we at least need value of either component. So we assume the capacitor value. So now we can calculate these resistor values. So for the low pass filter section, this is the formula, and you can just calculate this value. Then you can just bring this, the C value, and you can calculate this FL. Sorry, this FL is already given. We know that C value we assumed. What we don't know here is the RL value, right? The resistor value we don't know. So we just bring this RL here, and then we rearrange this equation and apply all the values. Then you will get the resistor value like this. And similarly for the high pass filter, the same. So we know all the values. We know the higher cutoff frequency. We know the capacitor value. We don't know this RH value. So we are just rearranging the equation and finding the value of this resistor in the high pass filter. So now we know all the values. So now from this we can calculate this FR. So FR is square root of, this is not FC, this is FR, or we can also call this a center frequency FC. So I do not want to use this FC because we also sometimes call cutoff frequency as FC. So we better use resonant FR, that is the center frequency, is equal to square root of FL times FH. So we know FL and FH 200 and 800. Then you will find the FR value like this. Then what is the bandwidth? The difference between the lower cutoff frequency and higher cutoff frequency. So FL, so here FH minus FL. So that is 800 minus 200, that is 600 hertz. So we reject this 600 hertz and we are passing only 1 to 200 and 800 to 1000. And we are blocking this 600 hertz. So here you can see one more new term. It's called the Q factor, quality factor. So what is the formula for this quality factor? Q is equal to FC, that is the resonant frequency we already found here. And this is the bandwidth. What is the bandwidth? This is the 600 hertz. So you have to just use this formula, 400 divided by 600, then you will get this one. And if you calculate in terms of by using the logarithmic table or the logarithmic formula, the same one you can get in terms of dB. So everything is the same, all are using the same formulas, and you have to find the bandwidth and the resonant frequency in order to find this quality factor Q. So maybe you will get a problem using this design the band stop filter. you can find maybe some values will be given and you have to find the missing values. For example, here is RH, and then you need to find this resonant frequency and you need to find the bandwidth. We will not ask this resonant and bandwidth, but we will directly ask you this quality factor. Of course, if you want to calculate the quality factor, you must need these two values that you need to calculate. So that's all about this band stop filter. And this is another problem. So here, this is the circuit given to you. You have to find the bandwidth and you have to find the bandwidth of this band stop filter. So you know what is this filter section and you know what is the filter section here. You have to first find the cutoff frequency 1, FC1 or FL. And here you have to find another cutoff frequency. And after that, you have to find the differences between these two. That is the bandwidth. So now if I ask you to also find the resonant frequency, then you have to use these two values and then find the resonant frequency. And also if you get a question about finding quality factor Q, then you have to find the quality factor based on this FR value and the bandwidth. So this is just another simple and straightforward problem. So here the main thing is the value of resistors and capacitors are very, very important because these are the values is deciding the cutoff frequencies. So only cutoff frequency is determining the frequency response of the filters.